All right, in this section, we're going to talk about something called simultaneity. It's a mouthful, but simultaneity. So, relative simultaneity. The invariance of the speed of light leads to problems with simultaneous events. Time intervals are related by simultaneity, or the idea that an event occurs in a definite location and time. Two events that are simultaneous in one frame of reference are not simultaneous in another reference frame, moving relative to the first reference frame, even if both are inertial. So let's look at some more details of what we mean by this. Okay, so this platform represents a high-speed train that's moving from left to right. So think of a train moving from left to right with respect to observer 2. So observer 2 is on a stationary platform and sees the train moving from left to right. Observer 1, which is here, 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 in 3 different iterations of the platform, is on the center of the moving train. So this observer considers their reference frame to be stationary. Each of these 3 moving platform train images represents a different point in time. So at the bottom is time 0, and then this is increasing time. Okay, so a little further in time, a little further in time. All right, so there are these 2 light pulses at A and B that occur simultaneously. So we release a pulse of light at the same time at the ends of the platform. And you can see they arrive at observer 1 at the same time. What else is happening here? Well, observer 1 on the train sees observer 2 moving past him as he moves to the right. He'll see observer 2 moving past him from right to left, but observer 2 sees observer 1 and the train moving from left to right. Now, observer 2 from his stationary reference point sees observer 1 pass him from left to right. But what about these light pulses? What does observer 2 see? Observer 2 from his stationary reference frame, the pulse from A will appear to move a greater distance to reach the center because the platform is moving away from that position. The pulse from B will move a shorter distance to reach the center because the platform is moving toward where the light was emitted at point B. Okay, we know the speed of light is the same no matter what reference frame you're in. So if observer 2 sees pulse A traveling further than pulse B, then that also means that observer sees pulse B arriving first, right? The time would be less for pulse B to get to observer 1, and pulse A would take longer to get to observer 1 here as the train is moving to the right. Okay, so observer 1 on the train sees the 2 initial flashes of light arriving at the same time. But observer 2 does not see them simultaneously. Observer 2 sees pulse B arrive first because it travels a shorter distance, and pulse A arrives second because it's observed to travel a farther distance. from the perspective of observer 2. Whether or not two events at different locations occur simultaneously depends on the state of motion of the observer. Events that are simultaneous in one reference frame, such as the frame of reference of the stationary observer on the train, are not necessarily simultaneously in another. In this case, the frame of reference of the observer sitting on the stationary platform watching the train go by. There is no basis for which of those reference frames is quote unquote correct. As long as a reference frame is inertial, observations in that reference frame will obey the laws of physics in that frame. Observations in one inertial frame may not be the same as observations in another. So, from the frame of reference of the observer on the train, we see the simultaneous event of the light flashing and reaching that observer. From the frame of reference of the person stationary on the platform as the train goes by, they see the two lights non-simultaneously, or arriving to the observer 1 at two different times. Both of those are correct from the frame of reference of each of those observers.